Hi Andy, let us know about read 7th class science lesson temperature and its measurement. In class 6 we learned about the different changes that take place in different seasons in the lesson. Changes around us. We wore different clothes in different seasons. We wear woolen and dark color clothes during the winter when it is cold outside. Woolen and dark color clothes keep us warm. We prefer to wear light colored cotton clothes when it is hot. They give us a feeling of coolness. You might have wondered why a particular type of cloth is suitable for a particular season. In winter, we feel cold inside the house. If we come outside in the sun, we feel warm. In summer, we feel hot even inside the house. How do we know whether something is hot or cold? We try to get answers to these questions in this chapter. Let us do. Some objects are given in the table. Mark these objects as hot or cold. Here ice cream cold గా ఉంటుంది, ఫ్రూట్ జ్యూస్ కోల్డ్, మెటల్ చైర్ kept in the sun hot, స్పూన్ ఇన్ ద కప్ ఆఫ్ హాట్ టీ, అది హాట్గా ఉంటుంది. We see that some objects are cold and some are hot. We also know that some objects are hotter than others while some are colder than others. How do we decide which object is hotter than the other and which object is colder than the other? We need to reliable method to decide the hotness or coldness of an object. Generally, hotness or coldness is expressed in terms of the temperature. Temperature means it is a measure of the degree of hotness or coldness of an object. Temperature is a measure of the degree of hotness or coldness of an object. By touching with our hands, we can guess whether the cup of milk is still worth sipping or has become too cold. Whether milk is hot enough for making curds, etc. But estimating temperature with our hands can sometimes mislead or confuse us. Let us do. Take some cold water, lukewarm water, and hot water in three different vessels. Immerse your left hand finger in the cold water vessel and right hand finger in the hot water vessel. Simultaneously wait for 2 or 3 minutes. Take off both your fingers and dip them in the lukewarm water vessel. What do you feel about the hotness of water now? Do both of your fingers feel the same hotness though both fingers are in the same glass of water? One finger will feel cold and another feel it hot. Look how our fingers are confused. Hotness or coldness are related to the observer. Can we exactly decide hotness or coldness of a subject just by touching it? Why? It is not possible to guess the hotness of a substance only on the basis of feel touch. It is certain that the water in different tubs has different degrees of hotness which cannot be exactly determined simply by touching. We feel hot when we sit in sunlight or near fire. We feel cold when we put a piece of ice on our palm. Have you ever thought why it is so? Think it over. When rice is being cooked, you observe the plate on the rice ball jumps. Why is it happening? Have you observed water boiling in a vessel with a lid on it? What do you notice? Have you seen the lid moving up and down and listen to the sound coming out of it? Where does the sound come from? Why the lid moving? Sometimes the lid might thrown away too. What is the reason? We know that boiled water is being converted to water vapor. The volume of the water vapor increases. The increasing volume of the water vapor tries to go out. In this process, it tries to lift the lid up. What makes the lid lift up? We need energy to lift any object. Does this energy come from? It comes from the heated water. Where did this water get energy from the heat of the fire? Thus the heat is a form of energy. We know that heat is a form of energy that transferred from an object at a high temperature to one at lower temperature. When we stand in the sun or near fire, heat energy enters our body and we feel hot. Why Juice is ice is put on our farm. Heat energy moves from our body to the piece of ice. That's why we feel cold. So the energy which makes an object appear hot or cold is called heat. The energy which makes an object appear hot or cold is called heat. Conversion of energy. Rub your palms together. How do you feel? Have you ever observed that iron becomes hot when it is beaten with hammer? Take a soap nut seed. Take a soap nut seed, rub it on a stone and touch it. How do you feel? In above cases, mechanical energy is converted into heat energy. In above cases, mechanical energy is converted into heat energy. అంటే ఇన్ ద ఫస్ట్ కేసు మనం పామ్స్ రబ్ చేసినప్పుడు కూడా అండ్ హ్యామర్తో అది కొట్టినప్పుడు కూడా ఏమవుతుందంటే అది హీట్ అవుతుంది అనమాట. అండ్ కుంకుడు గింజని మన స్టోన్ మీద రబ్ చేసిన తర్వాత దాన్ని టచ్ చేస్తే హీట్ అవుతుంది. ఎందుకంటే అక్కడ మెకానికల్ ఎనర్జీ అనేది హీట్ ఎనర్జీగా కన్వర్ట్ అయింది కాబట్టి. If you use electric heater to heat water, electrical energy is converted into heat. Likewise, if you use gas stove, chemical energy is converted into heat. In solar heaters, solar energy is converted to heat. In the above examples, different kinds of energies are being converted to heat. In the same way, heat energy can be converted to other forms of energy. You may have heard that in a thermal power station, heat energy is converted into electrical energy. In a steam engine, heat energy is converted to mechanical energy, which helps in moving the engine. Give some examples where heat energy gets converted into other forms of energy and vice versa. Heat and temperature. If you stand close to the fire, you feel warm. When a warm object is placed close to a cooler object, heat energy moves from the warmer object to the cooler one until both objects attain the same temperature. Often we think that heat and temperature are the same things. This is wrong. Temperature is a measure of the heat energy in a body, and which indicates the ability of the body to give heat to another body or absorb heat from another body. We use thermometers to measure the temperature. Have you observed any thermometer in daily life? Have you seen the thermometer used by doctors in hospitals? What does it contain? How does it help us to measure the temperature? Let us observe a thermometer. Now hold the thermometer and observe it carefully. What is it made up of? What is it made up of? What do you find inside the thermometer? What do you find at the both ends of the tube? How do they differ from each other? At one end of the tube, you observe a bulb. One end you observe one bulb, glass bulb like this, and it is filled with mercury. Glass bulb filled with mercury. And what do you observe at the other end of the tube? The other end of the tube is sealed after removing air from it. The other end of the tube is sealed after removing air from it. Do you find any markings on the tube? We find a scale which is marked to express temperature in degree Celsius. We read the temperature with the help of these markings. Read the markings on the tube. Where does it start? Where does it end? This arrangement of marks is called scale of temperature. This arrangement of marks is called scale of temperature. All thermometers are based on the fact that matter expands on heat. All thermometers are based on the fact that matter expands on heating. To understand the working of thermometer, we need to know how matter expands on heating. To understand the working of the thermometer, we need to know how matter expands on heating. Expansion of liquid due to heat. Take a flat bottom flask and fill it with a color. Take a flat bottom flask and fill it with a colored water. Fix a cork having a capillary tube in the mouth of the flask such that level of the water is as shown figure 9. They place the flask in a metal trough. Place the flask in a metal trough. Pour boiling hot water into the trough and carefully observe the level of colored water. What do you observe? If you take the flask out of the trough and keep it outside for some time, what do you observe? In the above activity, we see that water expands on heating and contracts and cooling. So does mercury. It is used as a liquid for indicating temperature in thermometers. Apart from mercury, we also use alcohol as thermometer liquid. Think, why do we use mercury or alcohol as thermometer liquids? Properties of mercury: it expands in uniform. Its expansion is uniform for equal amounts of heat. It expands by equal lengths. It is opaque and shining. It does not stick to the sides of the glass tube. It is a good conductor of heat. It is easily available in pure state. Properties of alcohol: it can record very low temperatures. It expands for degree Celsius. Rise temperature is very large. It can be colored brightly and hence is easily visible. How to use a thermometer? To find the temperature of an object, the bulb of the thermometer needs to be close contact with the object. Watch the shiny line of mercury in the tube. The highest point on the scale at which the rise of mercury stops shows the temperature of the object. Example: to find the temperature of your palm, place the bulb of a thermometer in the contact with the palm for 2 minutes and see the mercury rise. When mercury stops rising and its level becomes steady, note the position of its upper end. This is the temperature of your palm. How much is it? If marking a thermometer are wiped out, how do we create new markings? If the markings on the thermometer are wiped out, how do we create new markings? Take some ice in a beaker, immerse a thermometer in ice for 2 minutes and marks the mercury level. Now let the ice melt. Can you observe any change in the mercury level? The level of the mercury remains the same while ice melts. This means that temperature is constant. This constant temperature at which ice melts is called melting point of ice, and mark it as at 0 degrees Celsius. Take some water in a beaker, immerse the thermometer in it, and start heating the water. It will start boiling while getting converted into steam. Mercury level starts rising and reaches a point beyond the which does not rise. Mark the level of the mercury at this point. Observe the constant level at which mercury stays while water is boiling. This constant temperature is called boiling point of water. We mark the level of the mercury at this point as a 100 degree Celsius. The temperature at which ice melts or water boils is constant. These values are fixed as 0 degree Celsius and 100 degree Celsius respectively. Like water, all substances in pure form melt and boil at certain fixed temperatures. To create a scale, we need to fixed points. Let us choose the melting point 0 degree Celsius and boiling point 100 degree Celsius as two fixed points for the scale of the thermometer. Now divide the distance between these 2 points on the thermometer into 100 equal parts. Think about how we can achieve this. Each of the 100 equal parts represents 1 degree Celsius. We further divide 1 degree Celsius into 10 small divisions. It can be read as 1 by 10 or 0.1 degree Celsius. Now, can you precisely determine which water is cooler and which is hotter than the other in 3 beaker experiment? If the temperature of the beaker in which we immersed both hands is 41 degrees Celsius, what can be said about the temperature of water in other beakers? The beaker containing cooler water will record temperature less than 41 degrees Celsius. The breaker containing hotter water will record temperature more than 41 degrees Celsius. The first thermometer was invented by Galileo in 1593 AD. In this thermometer, air was used as a thermometric substance as air rapidly expands on heating and contrasts on cooling. Further, the substance that is used in thermometer has uniform expansion or contraction with the rise or fall in a temperature. Let us do you find any difference in the temperature of air in a shadow and in the sun? Do you know in Libya, Africa, on a particular day in the year 1922, it became so hot that the temperature of air, even in shade, was as high as 58 degrees Celsius. At some places, Kottagudem, Ramagundam in Andhra Pradesh, the maximum temperature of air sometimes reaches 48 degrees Celsius and more. When it is so hot, we feel extremely uncomfortable, as the normal temperature of the human body is 37 degrees Celsius. The lowest temperature in the world has been measured in Antarctica, where it once went down to about minus 89 degrees Celsius. The minus sign is used for temperature which is less than 0 degrees Celsius. So water freezes at 0 degrees Celsius. Just think how cold minus 89 degrees Celsius must be. In winter, when the atmospheric temperature around us becomes 15 degrees Celsius to 20 degrees Celsius, we begin to feel cold. In maximum, highest, and minimum lowest temperature of a day are measured by a thermometer called the 6s maximum the 6s maximum minimum thermometer. The maximum, highest, and minimum lowest temperature of a day are measured by a thermometer is called 6s maximum minimum thermometer. Clinical thermometer, generally when we are suffering from fever, our body temperature increases. Can you find how much the body temperature has increased? Doctors use thermometer to find out the temperature of our bodies. It is called the clinical thermometer. Hold the clinical thermometer in your hand and observe it carefully. There are two types of scales marked on the clinical thermometer. One that starts with the 35 degrees Celsius and ends at 45 degree is a Celsius scale, while the other starts with the 94 degrees and ends with at 108 degrees in the Fahrenheit scale. 94 degrees to 108 degrees in Fahrenheit scale. Do you see a kink in the capillary near the bulb? Do you see a kink in the capillary near the bulb? This kink prevents the mercury level from falling on its own. Reading the Fahrenheit scale on the thermometer. Reading the Fahrenheit scale on the thermometer. Note the temperature difference indicated between the two bigger marks. Also note down the number of divisions between these marks. Suppose two consecutive bigger marks differ by 1 degree and there are 5 divisions between them. Then one small division reads as 1 by 5 equal to 0.2 degree Fahrenheit. Reading the Fahrenheit scale on thermometer, note the temperature difference indicated between the two bigger marks. Also note down the number of divisions between these marks. Suppose two consecutive bigger marks differ by 1 degree and there are 5 divisions between them. Then one small division reads as 1 by 5 equals to 0.2 degree Fahrenheit. How to use a clinical thermometer? Was the thermometer preferably with an antiseptic solution? Hold it firmly by the end and give it a few jacks. Hold it firmly by the end and give it a few jerks. These jerks will bring the level of mercury down. Ensure that it falls below 35 degrees or 95 degree Fahrenheit. Now place the thermometer under your tongue or armpit. After 1 minute, take the thermometer out and note the reading. It tells you your body temperature. What did you record as your body temperature? 98.4 degree Fahrenheit. In the picture, first thermometer shows the body temperature of Srikar. Second thermometer shows the temperature of Srinath, who is suffering from fever. How can you say that? The normal temperature of human body is 37 degrees Celsius or 98.4 degree Fahrenheit, which is measured by clinical thermometer. Feel the body temperature of some of your friends by placing your hand on their forehead. Estimate the temperature and record it in the table. Measure it now with the clinical thermometer. Record your observation table. Thermistor thermometer. It is available in market to measure the human body temperatures, particularly for infants and children. It is available in market to measure the human body temperatures, particularly for infant and children. Digital thermometer, there is a lot of concern over the use of mercury in thermometer. Mercury is a toxic substance and is very difficult to dispose of it. A thermometer breaks. These days, digital thermometers are also available which do not use mercury. To measure the temperature of other objects, there are other thermometers. One such thermometer is known as a laboratory thermometer. Laboratory thermometer. Observe the thermometer in figure 22. It is a laboratory thermometer. Label the parts of it. Observe the markings of the laboratory thermometer. What is its range? What do you mean by minus degree Celsius? It is it less than the 0 degree Celsius or greater than it? How to use it? Take some tap water in a beaker. Dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom of the bottom or a side of the beaker. Hold the thermometer vertically. Wait till the mercury thread becomes steady. Note the reading, that is the temperature of water at that time. Reading the Celsius scale on thermometer. Note the temperature difference indicated between two beaker marks. Also note down the number of divisions between those marks. Suppose two consecutive bigger marks differ by 1 degree and there are 10 divisions between them, then the one small division is read as 1 by 10 equals 0.1 degree Celsius. Let us do this. Take some hot water in a beaker, dip thermometer in it for 1 minute. Record the temperature while the thermometer is in water. Take out the thermometer from water. Observe the mercury thread carefully. What do you notice after some time? Why we are advised not to use laboratory thermometer to measure our body temperature? Why? Think about the kink. How does the laboratory thermometer differ from clinical thermometer?